Hey there, Honors Bio. I'm stuck at home with a sore throat waiting on some test results, so we'll be doing this from here for now. I'm in my little corner of the basement, and we are starting Chapter 8. So, in order to start in Chapter 8, we're going to start by answering um, the kind of basic question of where does glucose come from? And we're going to answer that. Oops. We're going to answer that by playing a game, and the game is called Are You Smarter Than a Harvard Graduate? So, what I want you to do right now at your seat is get out a half sheet of paper and go ahead and just tear it in half. And on that sheet of paper, I want you to answer the following question. You ready? When you're done answering it, I want you to show it to your neighbor so that they know, they keep you honest, that you answered the way you answered. And that question is trees start as seeds and they don't weigh very much. And then they grow into big, huge trees that weigh like tons and tons and tons. Where specifically does that mass come from? Okay, like what is it and where did the tree get it? Mass can't be created, can't be destroyed. Where did the mass come from? Okay, from seed to tree. So take a minute, press pause. I'll wait, and when you're done answering it, show it to your neighbor. Have your neighbor show you theirs, and then you will get to watch actual Harvard graduates try to answer the same question that you just answered. Um, okay, go.
Cambridge, Massachusetts.
Here's a seed.
Okay.
Okay? Now hold on to that for a second.
Okay.
Imagine that I planted that in the ground.
Okay.
And a tree grew. All right? And here is a piece of that tree.
Sure.
Okay? Now, where did all that stuff come from?
So where do plants come from? You look at these beautiful big redwood trees, these great spreading valley oaks, and you know they start from this little tiny seed. It's miraculous. Where does all that weight come from?
Oh, the mass came from a lot of things, I'd guess. I'd guess from water that it sucked up from the ground. I would guess from minerals that it sucked up from the ground.
Water, light, soil.
Well, I mean, I suppose in terms of raw mass, most of it's probably derived from actual like matter in the soil itself, and some of it comes from water, obviously, but a large amount of it comes from the nutrients that the roots absorb from the soil.
Okay, now be honest. Did you answer the same way they did? Because when I do this in person, generally about 95% of my students answer exactly that, which is not something to worry about. I mean, Harvard graduates are making the same mistake that you made. So don't feel bad. Just feel amazed that you can get through 4 years of like the top college in the United States and still not know where tree mass comes from. All right, here we go.
Now, what would you say to someone who said to you that most of the weight of the tree came from the carbon dioxide in the air?
I would say I would have no idea. I'd have to think about that.
I would disagree because this is the same volume of air.
You
where
would
the
disagree.
was highly compressed. I would say that's very disturbing and wonder how that could happen.
It's a very strange idea that somehow the air, which they view as nothing, as weightless, as insubstantial, somehow makes a tree, a giant tree that weighs several tons. I mean, that's absolutely incredible.
That'd be hard to believe because carbon dioxide is, well, it's a gas, and it doesn't seem intuitive that you could add mass taking in a gas.
But that's where it comes from. Takes those carbon molecules and packs them together via chemical reactions so tight that you get this huge menace.
So yeah, surprising, right? Although it shouldn't be, because we know how important carbon is. It makes some sense that it's carbon in the form of carbon dioxide that trees, all plants, are taking in and packing together in such a way that instead of being a gas, it's a solid, right? So pretty amazing stuff to start us off, that's how that works. Now, this process, obviously, is called photosynthesis. We are going to have to go ahead and bring back something from last year, which is balancing equations. We touched on that during the enzyme lab, but so we have an equation for photosynthesis that has obviously carbon dioxide, which you just figured out, and water going in, and some energy being used to create then a molecule you know very well, C6H12O6, glucose, and oxygen. So again, I'm going to have you just kind of press pause and go ahead and try and balance that equation yourself. It's the thing where you're allowed to put coefficients, which are full-size numbers, to the left of each term. They affect the whole term, the whole molecule, and you do that on the left and the right to try to get the number of atoms the same on either side of the arrow. Go ahead and press pause and give your best shot at balancing that sucker, okay? All right, so what we find is that the number we have to use in just about every case is a 6, that there are 6 carbons here. We start with carbon and we put a 6 to the left of the CO2, and that balances carbon, no problem. Then we look at hydrogen. Hydrogen has 12 over here and 2 over here. So the best way to fix that is to put a 6 here. And so now we have 12 hydrogens here and 12 hydrogens here. Oxygen would be scary because it's in every term, except it's very nice that we have it all by itself over here on the right. And so if we add up the oxygens on the left side, this is 6 times 2 is 12, plus 6 times 1 is 6. That makes 18 on this side. We want 18 on this side. Right now we have 6 plus 2 is 8. If we now put a 6 on that one, it's 6 plus 12 is 18, and the whole thing is balanced with just a 6, and a 6. Don't think too much about that on Halloween. All right, so we'll check back in with your Harvard graduateness tomorrow. What makes this whole deal work is a special pigment called chlorophyll that is in the chloroplasts, and the thing that is special about chlorophyll is its electrons. Those electrons, okay, I want you to imagine your younger sibling, if you have one, or if you know a little kid who maybe your younger sibling sometimes gets a little bit hyperactive. Does that ring a bell? Like there's probably a trigger, right? Maybe it's his favorite video game, or maybe it's when she eats something that's high in sugar or drinks a Coke or whatever. But I want you to imagine that younger sibling in like a full-on, like practically epileptic fit of hyperactivity. You picture that? That is chlorophyll's electron when sunlight hits it. It absolutely goes bonkers and starts kind of vibrating, and then can be harnessed to do this whole process that we call photosynthesis. And this happens in that place called the chloroplast. We will leave that, I think, for Monday. We'll be back Monday. I will be back Monday. And yeah, so now I'm going to have you do a fairly short web quest on a really important molecule called ATP that we'll talk about on Monday. And then if you have any free time at the end of the period, please work on your guided reading. All right. I will see you guys on Monday, and have a great weekend. Happy Halloween, and I'll see you soon.